Picture this: 30 years, 3 Guinness World Records, one $100 million machine, and an ending nobody who commissioned it ever saw coming. By the time we're done, you will understand not just how this machine works, but why it exists at all, what it cost the landscape around it, and why the most remarkable thing about the Bagger 293 in 2025 might be that it's still running. But to understand any of that, we have to go back to the beginning. Origins and engineering. Birth, the story of the Bagger 293 doesn't start in a design office. It starts underground. Beneath the flat agricultural plains of North Rhine-Westphalia, in Germany's western Rhineland region, sits one of the largest deposits of lignite, brown coal, in the world. Lignite is not glamorous fuel. It burns dirtier and less efficiently than hard coal. It has a lower energy density. It's heavy with moisture. By almost every metric of coal quality, lignite is the bottom of the barrel. But it is extraordinarily abundant in this part of Germany. And in the post-war Reconstruction era, with West Germany rebuilding its industrial base and desperately needing cheap domestic energy, lignite became the foundation of the Rhineland's power economy. The mines at Hambach, Garzweiler, and Inden fed a network of thermal power stations that kept the lights on for millions of people across North Rhine-Westphalia. Here's the thing most people miss about lignite mining. The coal itself is rarely the engineering challenge. The coal seams at Hambach lie relatively close to the surface, between 30 and 100 meters thick, and the lignite cuts like soft clay compared to hard rock minerals. The real problem is what's sitting on top of it: the overburden. Up to 500 meters of soil, clay, sand, and gravel that has to be removed before a single ton of coal can be extracted. At the Hambach mine, the ratio of overburden to coal is approximately 6.2 to 1. That means for every ton of coal you want, you need to move 6 tons of earth first. At a production target of 40 million tons of coal per year, the mine needed to shift somewhere in the neighborhood of 250 to 300 million cubic meters of overburden annually, every single year. The bucket wheel excavator, the Schaufelradbagger in German, was engineered specifically to solve this problem. Rather than using a single large digging bucket on a cable, or blasting with explosives neither suitable for soft overburden, the BWE uses a continuously rotating wheel studded with multiple buckets. As the wheel turns, it bites into the overburden face in a smooth, uninterrupted motion, feeding material directly onto a conveyor belt system. It's a fundamentally different philosophy from conventional excavation. Not force, not impact, continuous, relentless consumption. The lineage leading to the Bagger 293 stretches back decades. The German company Krupp had built the iconic Bagger 288 for Rheinbahn, the Rhineland Coal Company, completing it in 1978. At the time, the 288 was the largest land vehicle ever constructed, displacing the NASA Crawler transporter that had carried Saturn V rockets to the launch pad. It weighed 13,500 tons, stood 96 meters tall, and could move 240,000 cubic meters of overburden per day. Extraordinary. Almost absurd. But mines don't stay still. The Hambach mine was expanding, going deeper, working new sections, and Rheinbahn needed more throughput. By the late 1980s and into the early 1990s, Rheinbahn commissioned TAKRAF to design the next machine. TAKRAF's backstory matters here, and it's almost never covered. TAKRAF stands for Tagebau Ausrüstens, Krane and Förderanlagen, open-cast mining equipment, cranes, and conveyor systems. The company originated as a Volkseigener Betrieb, a state-owned enterprise in the German Democratic Republic, East Germany. It built enormous mining equipment for the Eastern Bloc's lignite operations in the Satia and the Leipzig region. When German reunification came in 1990, TAKRAF was privatized and restructured, eventually entering a partnership with MAN to become MAN TAKRAF, the company that would build the Bagger 293. This is a detail that almost every Western documentary glosses over. The machine that holds the Guinness World Record as the largest land vehicle ever built was designed and manufactured by engineers with direct roots in East German heavy industry. The technical expertise that made the Bagger 293 possible didn't come from a single tradition. It came from the fusion of 2 separate engineering cultures meeting in the aftermath of the Cold War. Planning and development began in the late 1980s. Construction and assembly took approximately 10 years. The machine was completed and commissioned in 1995 at an estimated cost of $100 million, consistent with the cost of the Bagger 288 before it. What TAKRAF's engineers faced was a scaling problem of genuine difficulty. Making a machine bigger is not simply a matter of multiplying components. Every doubling of mass creates structural challenges that scale non-linearly. boom extending nearly the length of a football field experiences extraordinary stresses at its pivot point under continuous excavation load. The machine needed to rotate, travel, dig, and survive German winters, all with a crew of just 5 people. The solution was a modular steel framework of reinforced trusses, designed so that individual sections could be replaced on-site without decommissioning the whole machine. The 12 crawler tracks, each 3.8 meters wide, were designed to distribute the 14,200-ton weight so gently that the machine exerts a ground pressure of only 1.71 kilopascals, less than the pressure exerted by a human foot standing still. That single engineering fact tells you everything about the thinking that went into this machine. The rise. When the Bagger 293 was commissioned at Hambach in 1995, just getting it to the mine was an event in itself. The machine was assembled near its eventual operating site. These things are not built in a factory and shipped. You don't put a 225-meter machine on a truck. BWEs are constructed in sections at or near the mine, assembled from modular components manufactured at Tackraft's facilities, and then slowly, painstakingly walked into position on their own crawler tracks. The Bagger 293 moves at a maximum speed of 10 meters per minute. That's 0.6 kilometers per hour. A brisk human walk is roughly 5 kilometers per hour. This machine moves 8 times slower than you do on foot. What it lacks in speed, it compensates for in scale. That almost defies visual comprehension. The bucket wheel itself, 21.3 meters in diameter. Stand it upright and it's as tall as a 7-story building. It carries 18 individual buckets, each capable of holding more than 15 cubic meters of material, approximately 530 cubic feet. Each bucket load alone is roughly the volume of a standard garden shed. The wheel feeds a continuous stream of loosened overburden onto the machine's internal conveyor system, which transfers material to external belt conveyors stretching across the mining area to the spoil tips. At full operational capacity, the Bagger 293 can move 240,000 cubic meters of material per day. Engineers have recorded peak excavation days exceeding 380,000 cubic meters. That peak figure is the highest single-day excavation recorded by any land vehicle in history. To visualize 240,000 cubic meters, it's roughly equivalent to filling 96 Olympic-sized swimming pools every day. All of that is powered by an external electrical supply. The machine draws electricity through trailing cables, consuming a base load of 16.56 megawatts. Under full operational load, power consumption has been reported to reach upward of 56 megawatts, enough electricity to power a city of tens of thousands of homes. What made the Bagger 293's rise particularly significant was its relationship to the Hambach mine's expansion strategy. Through the late 1990s and into the 2000s, the mine was growing. Deeper cuts, wider sections. The Bagger 293, working in conjunction with the Bagger 288 and other machines in the Hambach fleet, was at the center of an excavation operation producing up to 40 million tons of lignite annually. That coal fed the network of RWE power stations, Niederelsom, Norarat, Frommersdorf, that collectively generated a significant portion of North Rhine-Westphalia's electricity. Here's what the official corporate communications from RWE and its predecessor Rheinbraun don't emphasize. The Hambach mine, at the scale enabled by machines like the Bagger 293, was also systematically destroying one of the oldest continuous woodland ecosystems in Central Europe. The Hambach forest had stood for 12,000 years. By the time the Bagger 293 was commissioned, roughly 90% of that forest had already been cleared for the mine's expansion. The remaining 550 hectares sat directly in the path of the mine's approved expansion boundaries. The Bagger 293 didn't cause the forest's destruction. The destruction began before it existed, but as the machine that carried the Hambach operations expansion through the 1990s and 2000s, it was the operational instrument of that erasure. And all of that, every engineering decision I just told you about, was just the setup. Because what comes next is where the Bagger 293's real story begins. Not in the mine. In the political and cultural storm that built for 2 decades and finally broke in 2018. The peak. Let me tell you exactly what the Bagger 293 is capable of at maximum output, because the numbers are so far beyond ordinary experience that they need to be stated carefully. At its peak, working continuously on a productive face of overburden, the Bagger 293 is excavating and removing the equivalent of a soccer field dug to a depth of nearly 30 meters every single day. If that volume of material were loaded onto standard railway coal wagons, it would fill approximately 2,400 of them every 24 hours. Over the course of a year, the Hambach mine's total overburden removal reaches between 250 and 300 million cubic meters. In raw earth-moving capacity, nothing on land, no other mobile machine ever built by human hands can match what this machine does. The 3 Guinness World Records the Bagger 293 holds underscore feed and peaks. This machine has less than 1 peak in this machine. It's 8 pounds. It's paperback. It's too hot. It's pals to buttons to. The Bagger 293 doesn't remain off. Heaviest land vehicle ever built. 14,200 tons. Tallest terrestrial vehicle, 96 meters, shared with the Bagger 288. Largest land vehicle, 225 meters in length. Comedy. These aren't narrow technical records that will be broken by some minor increment next year. They reflect a genuine engineering limit. The Bagger 293 sits at the outer boundary of what is physically achievable for a land-based, self-propelled machine, and the operational efficiency that comes with this scale is remarkable. 5 people. 5 human operators control this entire machine, a structure longer than 2.5 American football fields, taller than Big Ben. The operators work from a control cabin fitted with sensors, monitors, and automation systems, providing real-time feedback on bucket wheel torque, conveyor loads, track pressure, and boom stress. Most documentaries skip over this, but it's the most important part of the whole operational story. The ratio of output to crew is what makes the Bagger-class excavators genuinely irreplaceable for this type of mining. There is no fleet of conventional excavators and dump trucks that could match 240,000 cubic meters per day while being operated by 5 people. The economics are structurally different. BWEs eliminate the entire logistics chain of haul truck fleets, their diesel consumption, their maintenance, their drivers. The coal comes off the face and onto a conveyor in a single, continuous, uninterrupted process. This is also why RWE never seriously considered decommissioning the Bagger 293, even as the wider German energy debate began shifting under their feet. The machine's operational efficiency was, and remains, irreplaceable within the mining system it's part of. You can't simply replace it with smaller, more modern equipment and maintain the same output. The entire Hambach mine is physically designed around the operating geometry of large BWEs. At its peak, in the late 1990s and early 2000s, the Bagger 293 represented everything that German heavy engineering claimed to stand for: precision, scale, reliability, and the near-total mechanization of industrial labor. It was an engineering statement, a confident one. And the tragedy is, the engineers at RWE could already see the forces gathering that would eventually transform that statement into a question mark. The cracks. Here's the thing most people get wrong about the Bagger 293. Its problems were never mechanical. The machine itself has performed with extraordinary reliability across its operational life. There's no documented catastrophic structural failure. No dramatic collapse. No engineering disaster to point to. The cracks in the Bagger 293 story are not in the steel. They're in the assumptions that justified building it in first place. To understand this, you need to understand what lignite is, economically and environmentally. Lignite, brown coal, has the highest CO2 emission intensity of any fossil fuel used for electricity generation. Burning lignite to produce electricity releases roughly 40% more carbon dioxide per unit of energy than burning hard coal, and approximately twice as much as burning natural gas. The power stations that the Hambach mine feeds, Niediaussem and Neurath among others, are among the most carbon-intensive electricity generation facilities in Europe. When the Bagger 293 was commissioned in 1995, Germany had recently unified. The Kyoto Protocol was not yet in force. And the climate science linking fossil fuel combustion to atmospheric warming, while well established in scientific circles, had not yet become a political forcing function. From Rheinbraun's perspective, commissioning a $100 million machine with a designed operational life of decades made perfect economic sense. What the official press releases from Rheinbraun in 1995 didn't mention was that the political conditions allowing lignite mining in the Rhineland to continue at that scale were already beginning to shift. Germany's Energiewende, energy transition policy, was not invented by the coalition governments of the 1990s. Its roots lay in debates and policy discussions going back to the late 1980s and early 1990s. The original approval framework for Hambach mining operations granted rights through to 2004-05. The Bagger 293 was built into that timeline, but beginning in the late 1990s, two forces began colliding with that assumption. The first was the science. Each successive IPCC assessment report tightened the case that Europe's largest lignite mines, and Germany's in particular, were incompatible with even moderate climate targets. Third-party analyses placed the Hambach mine's operational footprint among the most CO2-intensive individual extraction sites in Europe. The second force was social. Beginning around 2012, environmental activists occupied what remained of the Hambach forest. Initially small, a handful of people in tree houses, the occupation grew into a sustained, years-long protest infrastructure. By 2018, those tree houses numbered around 40 to 80 occupied structures, connected by rope bridges and home to a rotating population of activists. What had begun as a fringe occupation became, through 6 years of persistence, a national symbol. In September 2018, the government of North Rhine-Westphalia ordered a major police operation to evict the Hambach forest occupiers. Thousands of officers entered the forest. Confrontations were filmed and broadcast internationally. And then, during the eviction, a journalist named Stefan Mein fell from a suspension bridge between tree houses and died. The eviction was paused. The story went global. Within weeks, 50,000 people gathered near Hambach in what became the largest anti-coal demonstration in German history. A court order halted any further forest clearance. In Berlin, the Coal Commission accelerated its work toward a formal coal phase-out recommendation. The Bagger 293 kept digging through all of it, but the world around it had changed permanently. The fall. This is where the story gets complicated, because the Bagger 293 hasn't collapsed. It hasn't been scrapped. It hasn't failed mechanically or been withdrawn from service. What's happening to it is slower and in some ways stranger than a straightforward fall. What's happening is that the justification for its existence has been legislated away. In January 2019, Germany's Coal Commission delivered its recommendation: end coal-fired power generation in Germany by 2038 at the latest. In July 2020, the German parliament passed the Coal Exit Law, encoding that timeline into statute. The law also established that the Hambach forest would be preserved, permanently protected from mining expansion. The Coal Exit Law set the end of lignite extraction at the Hambach mine specifically at 2029. Not 2038, but 2029, a decade earlier than the overall national phase-out deadline. I need you to think about what that means for the Bagger 293, a machine designed and commissioned in 1995 for mine with an operational horizon of 2045. A machine built with the explicit engineering assumption that it would operate for decades. A machine that was, by every measure of its performance, doing exactly what it was built to do. The $100 million machine, the world record holder. The machine that moved mountains of overburden for 30 years, feeding the power stations that lit up North Rhine-Westphalia. It has been told to stop, not because it broke down, not because a better machine replaced it, but because the political, scientific, and social consensus of a nation decided that the work it was doing could no longer be justified. The official story from RW frames the phase-out as part of a responsible energy transition, with substantial compensation payments to the company for the early withdrawal of its mining and power generation rights. The 2022 agreement between the federal government and RWE specifically brought the North Rhine-Westphalia coal phase-out forward from 2038 to 2030. With RWE committing to invest more than 50 billion euros globally in renewable energy and new gas-fired, hydrogen-ready generating capacity. What the corporate communications understandably don't dwell on is what the Hambach mine's 30-year operational history actually cost the landscape around it. Since mining operations began in 1978, the mine grew to cover more than 43 square kilometers. Entire villages were demolished and their populations resettled. More than 1,000 people displaced over the decades of expansion. The Hambach forest, which had stood for 12,000 years, was reduced from its historic 4,000 hectares to roughly 500 hectares. That's approximately 86% destroyed. The overburden deposited as the mine expanded created the Sophienhöhe, an artificial hill built from spoil, now towering 200 meters above the surrounding plain. It is the largest human-made hill in the world, a mountain of waste from a machine's work. And here is the detail that engineering records make clear but that the corporate timeline papers over. When the decision was made in the late 1980s to commission the Bagger 293, 1. Favor B. The environmental consequences of Hambach's expansion were already well documented in German environmental impact studies and regulatory proceedings. The decision to build the machine was a conscious choice to prioritize energy production over those consequences. The Bagger 293 was never an innocent machine. It was the instrument of a deliberate industrial policy. The Hambach mine will eventually fill with water, diverted from the Rhine River. The plan, already in development through the Neuland-Hambach-Gambach-Hem Regional Transition Body, envisions the former mine becoming a large lake. The spoil tip of Sophienhea will become a forested hillside. The pit will become a lake. The Bagger 293 ate the mountain. The mountain is now a lake. Legacy, and where are they now? As of 2025, the Bagger 293 is still operating in the Hambach mine. Mining operations at Hambach are continuing within the existing approved boundaries, no further expansion, no new forest cairns, working down through the remaining coal reserves toward the 2029 cessation date. RBU's production figures for Hambach have declined significantly from the peak of 40 million tons annually. Current estimates suggest production running at roughly half that rate as the mine winds down. The Bagger 293 is doing what it has always done. Slowly, methodically, bucket by bucket. What becomes of it after 2029 is genuinely uncertain. The machine cannot simply be driven away. Nothing moves this machine anywhere quickly, and there is no comparable mine in Germany still operating at the scale that would justify its deployment. Disassembly and scrapping is the most economically rational outcome once operations at Hambach cease. The Bagger 293 is built from approximately 14,200 tons of high-grade structural steel. At scrap values, that material has significant worth. The modular construction that made the machine maintainable also makes it, in theory, dismantleable section by section. There is no publicly announced plan to preserve the Bagger 293 as a heritage monument. Unlike the Bagger 288, which famously made a remarkable 22-kilometer overland journey to the Garzweiler mine in 2001, crossing the A61 motorway, the Erft River, and several road systems at a cost of approximately 15 million German marks, taking 3 weeks to complete. The 288 continues to operate at Garzweiler, given that mine's later phase-out timeline. The technological legacy of the Bagger 293 is more complex to assess. The SR's 8000 type design, that Tackraft developed, represented in 1995 the practical engineering limit of bucket wheel excavator scaling. Subsequent developments in BWE technology have not pushed toward larger size. Instead, the industry's engineering focus has moved toward automation, GPS-guided excavation planning, real-time structural monitoring, remote-controlled operation. The trend is toward fewer operators, not larger machines. The Ferropolis Open-Air Industrial Museum in Saxony-Anhalt, sometimes called the City of Iron, preserves several decommissioned East German bucket wheel excavators as outdoor exhibits, hosting music festivals beneath their looming frames. Whether the Bagger 293 ever finds a similar afterlife seems unlikely given its sheer scale, but the cultural instinct to preserve these machines as monuments to an industrial era is genuine and increasingly recognized in Germany. I've spent a long time with the story of this machine. I've read the engineering specifications, the mine planning documents, the coal commission reports, the environmental impact studies, and the accounts of the activists who lived in the trees above the pit where it worked. Is the Bagger 293 the greatest land vehicle ever built? By every objective engineering measure, mass, dimensions, earth-moving capacity, operational efficiency, yes. The answer is simply yes. Nothing that moves on land has ever matched its scale, and nothing currently under development will. It is a genuine apex of a particular engineering tradition. And that tradition, German bucket wheel excavator engineering, developed across a century, produced something that exists at the outer boundary of what physics and metallurgy allow. The Bagger 293 is also the instrument that removed the overburden from the last 86% of a 12,000-year-old forest. It is the machine that processed the geological material above the coal seams that powered one of the most carbon-intensive electricity generation complexes in Europe across 3 decades of accelerating climate change. It moved mountains efficiently, and what was beneath those mountains helped warm the planet. And here's the thing that I keep coming back to. The thing that makes this machine's story genuinely complicated in a way that most heavy machinery stories are not. The people who built the Bagger 293 were excellent engineers. They solved a real problem with extraordinary skill. The people who operated it were professionals doing a job that kept the lights on for millions of people. The corporation that commissioned it made decisions that were legal, economically rational, and politically supported at the time. None of that makes the outcome different. The Bagger 293 is the most vivid single object in a larger story about how industrial civilization, has met its own consequences. It did not eat mountains because it was malicious. It ate mountains because it was designed to. Because we needed the coal. Because the permits allowed it. Because the economics made it rational. Because the scale made it efficient. And because nobody who signed the original contracts in the late 1980s fully reckoned with the world those contracts would eventually produce. 30 years later, Germany has decided to stop. The pit will fill with water. The forest remnant will be preserved. The machine will be disassembled, and its steel will go back into the industrial cycle. And the Bagger 293 will have been the most powerful machine that ever worked the earth in the age of carbon. The last of its kind, the largest of its kind, and the clearest physical monument to a set of decisions that an entire civilization made together and is now, slowly and imperfectly, trying to unmake.